Hi, Carly. I conferred with Michael, and what we were doing was exactly what we should have been doing, so it's good to know we were on the right track. So this one just, it doesn't come out to like a nice neat ratio like the other ones. It just comes out, and I've got all the steps here written out for you just to save a little bit of time on the video. And we got this far, but I think I kept the sheet and didn't send it home with you. So if you want to follow through step by step, you and I had done this so far. And then the next step, because there's not really, other than just simplifying 2 divided by 2 there's not really any more simplification that can be done here. And so you're just going to be substituting in for infinity, basically. It's kind of like when you find a horizontal asymptote. The n and the 4 and the 2n really are insignificant when you have an n squared and you're going to put infinity in. And so you basically end up with like 3 over 3, which is 1, which means that it does not converge using the ratio test. So after that, let me see. What he actually did was, so it's 1, so it does not converge. So I think we're going to stop there. I don't think we have to keep going. I think we're just testing to see if it converges or not. And I know on the back of the book it said diverge, and I'm trying to think what other test we would use, because this is going to fail. It's going to fail the p-test, right? Like if we do the p-test on it, then we're going to get p equals 0, because the 2 degrees are the same. It's both squared. I don't really know what other test we could do on it in order to show that it diverges, but if it doesn't converge, in this case, I guess we have to assume that it diverges. So we're right on the right track. I guess that's the important thing. If you see one like this, then follow the same steps that we were doing, and you should end up where you need to in terms of deciding here on the convergence or divergence. Okay, so I hope that helps, and good luck on your quiz tomorrow.